1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! That's right, guys. Welcome to Mr. Moore's online classroom. Alright, the whole point of this, remember, is that you learn mathematics where and when it suits you best. That's right, you can watch me from wherever you want in your house. You can watch me from the comfort of your own couch, which I imagine most people probably do. But a number of people said they've watched me other places in the house. You could watch me maybe from your bedroom, or you could watch me in the kitchen whilst you cook dinner. Some people have even said you could watch me whilst you're on the toilet, but I do not want to know about it, okay? Alright guys, so we've got plenty to get through today. We're going to be learning all about rates of change of polynomials. Okay, so make sure you make yourself comfortable, you maybe put your feet up, grab yourself a hot chocolate, grab a pen and some paper so you can write down some notes, and let's get stuck straight into the lesson. You know what? I know what you're thinking. You're wondering, why did I choose to wear the penguin onesie today? Well, yes, I do like to dress up sharp, and yes, this is probably the closest thing I own to a tuxedo, but it's something that's not related to that at all. It's something totally different. Okay, the reason I chose to wear my penguin onesie is because it's a little known made up fact of mine that penguins can only slide down on their stomach if the gradient of the hill is steeper than negative 0.3. So what we're going to do is we're going to have a look at a function right now and see if the penguin can slide down to a certain point.
Alright, so let's have a look at a worked example for the problem I just alluded to before. Now, it's an unknown made-up fact that penguins can only slide on their stomachs when going down an iceberg that has a slope steeper than a negative 0.03. The graph at right is modelled by the equation y equals negative 0.04x squared plus 4 and depicts the shape of an iceberg that Mr. Moore saw in Antarctica, where x is the horizontal displacement from the tip of the iceberg, and y represents the height of the iceberg. Okay, so let's just explain that in other words. We have an iceberg here. X is actually the displacement from the tip of the iceberg, so that's how far across, and y is the height of the iceberg above the water. So the question asks, at a horizontal displacement of 4 meters, will the penguins be able to slide? Okay, so to be able to do that, we need to be able to find out the gradient at x equals 4 and see if it's actually steeper than a negative 0.3. So to find the gradient, I need to know 2 points. Well, we'll use x equals 4 because that's actually where we want to find it. And let's use another point that's nearby, let's say x equals 3. Right, well we know our x coordinates, we now need to find our y coordinates. So we're going to use the function above. And substitute x equals 4 into this function. So substituting in now, you'll see I've swapped x over for 4. And 4 squared being 16. And when I simplify this, I get an answer of 3.36. Therefore, the coordinates of this point is 4 and 3.36. Okay, we're going to do the same now for x equals 3, so write out the equation. Substitute 3 for x, and 3 squared of course equals 9, and when we simplify this we get an answer of 3.64. Therefore the coordinate of this point is 3.64. Now to find the gradient between these 2 points we need to use the formula m is equal to y2 minus y1 over x2 minus x1. Alright, let's go through and label the points. We have x1 y1 and x2 y2. Let's substitute those points in now. You got y2 being 3.64 minus y1 being 3.36 over x2 being 3 minus x1 being 4, which end up getting us 0.28 over negative 1, which ends up being equal to negative 0.28. Now according to our calculations here, our gradient is actually smaller in magnitude than negative 0.3. Therefore the gradient of the slope, or the gradient of the iceberg at the point x equals 4, is not steep enough for the penguin to slide down on its stomach.
But Tom, we can get 2 points that are closer together.
Okay Jerry, well that sounds like a fair point. How about we change x equals 3 for maybe a point closer, like x equals 3.5? Okay, so subbing in x equals 3.5, we need to write out the equation first of all. Substitute in x equals 3.5 for x now. Now 3.5 squared is equal to 12.25. And when we simplify this, we get an answer of 3.51. Therefore, the coordinates at this point is equal to 3.5 and 3.51. Now let's substitute this new point into the equation with our old point. Okay, so let's call this one x2 and y2, and we'll substitute these 2 points into our equation for the gradient. So m is equal to y2 minus y1, so 3.51 minus y1 being 3.36 over x2 being 3.5 over x1 being 4. Therefore it is equal to 0.15 over negative 0.5, which is equal to negative 0.3. Oh, wait a second, just by changing the point to being a little bit closer, we can now see that our gradient is equal to negative 0.3, which is how steep it needs to be for the penguins to be able to slide down. But as we can see, we've just got negative 0.3, so it's only just possible for the penguin to be able to slide down.
But Tom, we can still get closer.
Okay, so because Jerry seems to believe that the gradient is actually steeper than negative 0.3, then we're going to actually substitute in 3.99, because 3.99 is a fair bit closer to 4. Okay, just written the formula and substitute in x equals 3.99 into the equation, and when I fully simplify that, I get an answer of y equals 3.363196. Therefore the coordinates are equal to 3.99 and 3.363196, this being our x2 and this being our y2 value. Okay, so let's substitute these into the formula for the gradient. y2 being 3.363196 minus y1 being 3.36 over x2 being 3.99 minus x1 being 4. This ends up getting us an answer of 0.003196 on the top over negative 0.01. This giving us an answer of negative 0.3196. Okay, so we can see here, just in getting a point a little bit closer to 4, we've actually taken the gradient of these 2 points up to an answer of negative 0.3196. Therefore the gradient is in fact actually getting steeper the closer we get.
So could the penguins slide down on their stomach? Yes, they could. Now there's a special type of penguin that actually is a little bit larger than the other penguins and needs a bit of a steeper slope in order to be able to slide down on its stomach. Alright, this special penguin actually needs a slope steeper than -1. This type of penguin is called the Mr. Moore penguin.
Okay, let's have a look at this. The furthest displacement from the tip of the iceberg can be seen to be 10 meters. Therefore we're going to find out, see if what the steepness of the gradient is at 10 meters, because clearly by looking at this graph the steepest point is going to be at x equals 10. Now of course, to find the steepness of this iceberg we need to have 2 points. Now remember, we want to go as close to it as possible, so we're going to choose the point x equals 9.99. Okay, so just written out the formula and substituted x equals 10 into the equation, and we get an answer of y equals 0. Therefore the coordinate of this point is equal to 10, 0. Okay, so now for the point x equals 9.99, written out the formula once again and substituted in x equals 9.99. So this ends up giving me an answer of y equals 0.007996, and the coordinate of course is 9.99 and 0.007996. Okay, the equation for the gradient, our x1 and our y1, and our x2 and our y2, substituting in now. So after simplifying this, you end up getting an answer of 0.007996 over negative 0.01, which ends up getting me an answer of negative 0.7996. Because Mr. Moore needed a slope of -1, and the gradient of the slope at its steepest point is equal to negative 0.7996, the Mr. Moore penguin can't actually slide along on his stomach.
So could the Mr. Moore type of penguin slide down on his stomach? Well, let's have a look. Now, it's not always possible to find the instantaneous rate of change for every single function. In fact, for some functions, the instantaneous rate of change doesn't even exist. Now, these types of functions are called hybrid functions. And what better way to explain instantaneous rate of change in hybrid functions than with the hybrid car, the Toyota Prius?
Now, as you can see, we're currently looking at a hybrid function. Now, the rate of change will only exist for a function if the graphs have a smooth gradient at the points where they approach each other. So what does this actually mean? Well, I've actually brought in a hybrid car to help us out with understanding hybrid functions. Now, if the Toyota Prius can make it from one end of the graph to the other without crashing or doing any damage to itself, then the rate of change exists. As we can see, the Toyota Prius ended up in a rather bad way. Therefore, the rate of change does not actually exist at x equals 0 for this function. So will the Toyota Prius be able to avoid suffering any damage from this graph? No, it couldn't, because the gradient's not the same at the point where the two functions meet. Therefore, the rate of change does not exist for this point. As shown by the empty dot at the point 1, 1, it can be seen that the function does not exist for x equals 1. So this is kind of like having a giant pothole in the middle of the road. So therefore, will the Prius get damaged? Bang! And the Prius has lost its front bumper. Therefore, the rate of change does not exist for x equals 1. How about this graph? Do the gradients look the same at the point where the two functions meet? Hurrah! Now, how do we know if the gradient's the same and the rate of change actually exists? Well, let's have a look at a worked example. Okay, so we want to actually have a look and see if the gradient here at x equals 1 is the same for both functions, because if it is, then the Toyota Prius can drive along without actually crashing. Now, to do that, we need to obviously note both functions. The first function for anything less than x equals 1 is y equals 2x, and of course, that is up here. And the second part of this hybrid function is for anything for any x value greater than 1, y is equal to x squared plus 1. So that there is represented by this function here, the hybrid function. Okay, so how can we tell if the gradient's the same at this x equals 1? What we're going to do is we're going to use x equals 1 for both functions and a point right next to it as well. So let's have a look at y equals 2x. And we're going to substitute in 2 points that fall on the y equals 2x line, knowing that for this function it only exists for less than 1. So let's just substitute in x equals 1 and x equals 0.99, because x equals 0.99 falls on this function, and as does x equals 1. Okay, substituting x equals 1 now. And you end up getting an answer of y equals 2. Therefore, the coordinates at this point is 1, 2. Alright, let's do the same thing for x equals 0.99. And you get the coordinates 0.99 or 1.98. Okay, now let's substitute that into the formula for gradient. Okay, so let's label our points. We've got x1, y1, x2, y2. So we get 1.98 minus 2 over 0.99 minus 1, which gets us negative 0.02 over negative 0.01, which ends up getting us an answer of 2. Therefore, the gradient for this function here is equal to 2. Okay, so let's have a look at the gradient of the y equals x squared plus 1 function. So y equals x squared plus 1. And of course, we need 2 points on this line, so we use x equals 1 once again. And we'll use x equals 1.01 because we want to find something that's just past this point, because that's what's on this line. Okay, substituting x equals 1. And you get the coordinates 1, 2. Substituting x equals 1.01. you get an answer of 2.02. Therefore, the coordinates at this point is 1.01 and 2.02. Alright, once again, let's substitute into the gradient function. So you got m is equal to y2 minus y1 over x2 minus x1. Label the points x1, y1, x2, y2, and you end up getting an answer of m y2 minus y1, so 2.02, 2 minus y1, 2, over x2 minus x1, 1.01, minus 1, ends up getting you an answer of 0.02 over 0.01, which therefore the gradient is equal to 2. So because the gradient for this function here is equal to 2, and the gradient for this function here at the point where they meet is equal to 2, it's a smooth gradient and the Toyota Prius can survive and drive up without getting any damage done to it.
Alright guys, I hope you enjoyed learning about rates of change of polynomials, and in fact it's actually the last lesson for this topic. So make sure you stay tuned for the very next topic, which is all about differentiation and calculus. Okay, it actually follows on nicely from the concepts that we've just covered. So like always, say hi to your maths teacher for me. Morsey out.